Sometimes, all it takes to change the world is just a little push in the right direction. Just the slightest of nudges. The time has come for consumers to have a single GPU that is capable of running multiple operating systems at once. Really, multiple jobs at once, but multiple operating systems probably get your attention better. All of the pieces needed to change the future now exist. They just haven't come together exactly right yet. But this is what I've been working on for years. If you've played Half-Life, you should know that I've sort of been playing the role of the G-Man, or a little bit, sort of, kind of. Trying to make sure that the right people are in the wrong place, because that can make all the difference in the world. As a computer scientist, I'm telling you that our personal security and privacy depends on having this technology. And as an internet rando and YouTuber, I want to show you what the future can be such that it gets you excited. At least I want to give you the tools to imagine it, because it's not quite here yet, but we're getting close. I want you to see it the way that I do. And if buyers know to demand it, then there will be a market for it. But I don't think anybody knows to demand it. Not really. A few of you do, but not everybody. With this technology unlocked, it'll lead ultimately to a much better ability for we, as sophisticated consumers, to better secure ourselves. GPU-accelerated apps and games can run inside of sandboxes, virtual machines, isolated from the rest of our computing life. I want your computing experience to be as software and operating system agnostic as possible. Virtualization and virtual machines are the way to do that, or some variation of virtualization, like containerization, para-virtualization. I want you to have easy access to your own hardware, wherever it might be, but I also want you to have the tools to fight back against being held hostage by, must-have services that are only, cloud subscription based. That's sort of a worst-case scenario. Why can't you just run it on your hardware, wherever it is? So in order to head down this path, we need two things. One, hardware support for doing this. And two, the software stack. Well, we have the software stack, open source, completely, fully ready to go, and we support SR-IOV and accelerated gaming virtual machines, and I'll talk more about that in a second on the software side. The hardware support is a little bit more nuanced. Anyone that's been following me for any length of time knows that, I love hardware pass-through. Hardware pass-through and taking, basically, I guess what this means is taking a fast killer machine and setting it up with two GPUs. One GPU runs on the host, and the other can be passed through to a virtual machine. So you can run two operating systems at once, or three operating systems at once, or four operating systems, limited only by the number of GPUs you have. This is my lab behind me. This is a dual Xeon 6258R from Intel and box. It has perfectly working PCIe reset. It's a great workstation, and it has gobs memory bandwidth. 56 cores of awesome, and it has handled everything that I've thrown at it. And in this corner, I've got a 64-core Threadripper, also fast and powerful, but some rough edges around the PCIe implementation, reset, and the like, so I've been working on that. But it does set the high watermark for price to performance ratio. It is similarly a virtual machine monster. In this way, with these machines, I can run Linux as my host OS and a Windows virtual machine, or 2 or 3 or 4, for gaming or anything else that needs GPU acceleration. Workstation stuff too, but we can talk about it in a gaming context. I can even run Mac OS, but don't tell Apple. It is a bit wasteful, however, I will concede, to have two GPUs in these machines, because it's rare that both GPUs are actually busy at once, because one's in the guest, one's in the host. I'm not playing a game in both of those, obviously. It would be nice if you could just share one powerful GPU with the two operating systems at the same time. That's sort of the holy grail that we're looking here for, and I don't know why it hasn't. The technology for this kind of exists. Kinda. The current industry standard is called SR-IOV, Single Root I/O Virtualization. It's used in servers and has been for years. It's a technology that's used more for security than efficiency, though. Here's my FirePro S7150. It does really well. It's pretty old by graphics card standards, though. These were end of life in 2017. NVIDIA also has Grid, an alternative to SR-IOV, but it's not open. It costs more than just buying more GPUs. So again, in this context, in the server context, it's really been more about security than convenience or density. This technology exists really just for servers, not for consumers. It's not ever really treated as a cost-saving measure. I mean, we got two of these Tesla cards. These are $10,000 V100s. And you also have to get a pricey grid subscription on top of that in order to slice and dice these GPUs up so that they can be used by more than one operating system at once. I actually did a video on that a while back, which is fun. 32 gigs of HBM on this thing is insanely fast. I mean, it's basically the same as a Titan V when you run it in a VM, when you have to give the whole thing to the VM. So now that's plenty to have a great gaming experience in a virtual machine, and you're also sure that the game's DRM isn't snooping anywhere it shouldn't, and it isn't selling my data or building a marketing profile or anything like that, because it's running in a sandbox. Also note, there's no outputs. Like if you look on the edge of the card, there's no outputs on either the S7150 or the V100. They're just nothing. There's nothing there. They don't physically support output, but it must be done in software somehow. Well, recently, Intel also caught my attention with their XE graphics and their One API. This is something for us to watch. See, I've worked with Intel's GVTG, which is an alternative to SR-IOV, and in fact, I talked to some folks at Computex in 2018 about GVTG on the Xeons that were running it at the time, which were the Xeon E3. You see, it works really well on those E3 Xeons with their iGPU. You can dynamically allocate that iGPU to a VM or 2 or 3 or 4, and it works exceptionally well. But divvying up that iGPU, that's not really that much GPU horsepower to begin with. But with the new XE graphics and improved support for that kind of thing through One API, it sure looks like this tech could be disruptive. Everything Intel described, from their zero-copy frame buffer implementation to how they plan to handle 1,000 720p Dota clients on a single PCIe card, this type of technology is exactly what we need in the consumer space as well. Everything that Raja Koduri was saying in the presentation was basically like the checklist of stuff that we've been working on and stuff that we've learned from working on the Looking Glass project. So when the RTX 3000 series launched, NVIDIA said, oh, this silicon supports SR-IOV, but it hasn't ever been enabled. And as of today, it's still not usable on consumer GPUs in the RTX 3000 family. Now, NVIDIA and anyone listening that makes GPUs, I'm telling you, we have the full software stack to support consumer virtual machines with a frame buffer in Looking Glass right now, here today. Looking Glass is open source software. It is fully ready to go. We are ready for that SR-IOV use case to be enabled tomorrow from any vendor. Not even necessarily SR-IOV. On our end, it's plug and play. It has full SPICE support for the guest clients built right in, and it supports frame rates greater than 60 Hertz, which is not something you can say of like Grid, for example, or at least I had trouble setting that up. It seemed like it was kind of going to work, and then it didn't. One of the other big missing pieces until very recently was GPU scheduling. It was missing from operating systems. Windows didn't even support it. The same problems that I'm talking about here were already applicable for gamers. They just didn't know that the two things were related. Remember Apex Legends? OBS's streaming problem with Apex Legends? That game was designed to use whatever GPU resources you have available, and it didn't leave any room for compute. So there weren't any compute resources open for Open Broadcaster. The fix? Ultimately, a GPU scheduler in the operating system. Well, this lets different tasks from the same operating system schedule things on the GPU. The GPU can be shared sort of cooperatively among different, heterogeneous tasks that are running on the machine. Now, with AMD and their RX 6000 GPUs, AMD also just added a cache, just like CPUs. So GPUs are starting to look like CPUs. Now, SR-IOV is more like a hard partition. I think something like Intel's GVTG is more the future, especially if it's open. And if it's as open as Intel says it is, everyone is going to adopt it, at least what has become, I think, GVTG and Intel's Open One API. Oh, and by the way, you can do SR-IOV on a card that was not meant for it. For example, these S7150 are still so expensive. They were at their end of their life like 3 years ago, but they weren't really, they're passively cooled, which means you got to use them in a server or 3D print a fan adapter. It's not great. Using this on a desktop motherboard, you definitely have to 3D print some kind of fan adapter to force air through here. But they support SR-IOV, but a lot of desktop boards don't really support SR-IOV because of the PCIe ROM bar issue. Oh wait, smart access memory is kind of changing the SR-IOV ROM bar space problem. See, the problem with the PCIe ROM bar space is there wasn't enough on desktop boards. And yes, I've modded BIOSes for folks in the community, but with smart access memory, we might not actually need to do that anymore. Boards such as the ASRock Tai-Chi, which enable SR-IOV for network cards, can now also work with SR-IOV GPUs and smart access memory. Well, I haven't tested extensively yet. That's going to have to be a future video, but I'm thinking the answer is yes, because otherwise you don't get posts. So, there's this W7100. It doesn't support SR-IOV, but it can be modded into the S7150. So the S7150 does support SR-IOV. So in a lot of ways, this actually ends up being a better SR-IOV card because it has a fan, unlike the W7150. And both of these cards, to be sure, were end of life 3 years ago, so I don't know how much. I don't think it's going to change any like market value proposition. I don't think anybody's going to run out and buy these cards because they've been end of life forever. And the performance on this card isn't great. I mean, it's a 3-year-old card, so we're talking about as fast as an RX 470. But this is useful for developers that want to experiment with SR-IOV. So if you can get one of these for cheap, I'd say around $100, and you want to mod it, you will most likely have to replace an EEPROM, although a couple of them have EEPROMs that are large enough to hold the different BIOS. You basically just have to flash another BIOS on here. It's not really a big deal. So for now, I think, though, the best approach for running a virtual machine with its own GPU is still just have 2 separate GPUs. Gaming natively in Linux is also better than it's ever been, which, sort of obviates the need. But I still prefer this approach, which admittedly is costlier and more complex, if for nothing else because of the security and sandboxing aspects of this. Now, one other key thing I want to drive home is that consumers are ready for sharing a GPU with multiple operating systems. We have the software stack. Looking Glass can easily support this use case. We're already working fine, maybe even great, with these existing hardware cards that support SR-IOV. So any future technology that comes along for the same kind of thing, like what we see in Intel's, One API, we can support. All we need really is a gaming GPU with some way of giving us device and frame buffer access inside a virtual machine. It doesn't even really need to be SR-IOV. It could be any of the other technologies, whatever a vendor is willing to open up. It would probably also be good if it handles dynamic resource allocation pretty well, so that you're not, doing a hard partition like SR-IOV. With this in place at a software level, it should make it possible for us computer scientists and software developers to give the end users the safety, privacy, and security of running everything inside a virtual machine. This is the philosophy behind Qubes OS. If you haven't seen it, you should check out that project. The philosophy here is awesome, and the philosophy is to make it as frictionless as possible for end users to sandbox apps, spin up virtual machines, and just compute safely. Is that app spying on me? Well, run it in a sandbox, and it can't see anything but itself. Even Windows is getting sort of clued into this kind of thing. There's native support in Windows for something called Windows Sandbox. We did a video on that too. But Windows Sandbox is a frustrating, half-baked, punishing nightmare because this feature breaks support for other virtualization stuff like Hyper-V and VirtualBox. Theoretically, it does offer low-friction disposable Windows sandboxes, though, where you just click a button and you're up and running with a Windows virtual machine. Don't even have to install Windows. And it's ethereal, meaning that when you turn it off, it's deleted, gone. And I think this is sort of basic computer hygiene that everybody needs. Does this game's anti-cheat need access to my personal finance spreadsheets? Is this game's DRM building a marketing profile on me to monetize later in some way? Moving to this sort of compute philosophy where apps kind of get isolated has got to become a basic part of the mindset for anyone who computes, just for basic privacy and security. Oh, and by the way, Qubes doesn't want to do hardware PCIe pass-through or anything like that because the security isn't high enough. And while they're not wrong, not enough of we who would spend money are clued in enough to demand these requirements from the market. So these features never really get built out, and so we just sort of end up being in this security and privacy nightmare where we are. So in short, here's the proof positive that we are ready to fully support SR-IOV or alternative technologies like Intel's GBTG in a consumer and enthusiast space. The software stack is ready to go. Now, personally, I feel somewhat responsible for VFIO becoming its own sort of computing enthusiast subculture. And I will see my vision of what it could be in terms of user privacy and security and isolation through as best I can, at least until it's fully realized, because I think that's really important for the future of computation and the least amount of headache for everybody involved. I think it's a great solution. We'll DIY hardware support for SR-IOV if we have to, check out that vid. By the way, that's a different vid. It's probably up on Patreon already. If you would like to support the Looking Glass project because you're into this kind of thing, there's links for that below, and I would really appreciate that. You can directly support Looking Glass, and that's awesome. The support of our fans are what makes these kinds of things possible, and you can directly support Level 1 in addition via Patreon, FloatPlane, buying stuff from our store, or just getting the word out. I appreciate each and every one of you. Thank you for helping me make these kinds of videos possible, these kinds of projects possible. I'm Wendell, this is Level 1. Thank you for watching. I'm signing out, and I'll see you in the forums.